Hey guys, how you doing? This is Sasfai, and today we will try to see how we can delineate a watershed by using the digital elevation model or digital terrain model or DEM data. So first we have to install the GIS software on your computer or on our computer. But for the time being, I have GIS 10.5 installed on the PC. Then in this software, you can analyze different spatial data based on the right procedures that has to be employed in order to do the facts. So now I have to add the data to the active data frame of the map. So in order to do that, you may click the plus sign here and go to the folder that the file is saved, and you can import it into the data frame of the GIS software, or you can go to file, file, add data, then add the data. You may use one of the two, but this one is a little bit longer with pause, so the shortcut is found here. So you can click on it. You have to go to the folder where your data is found. My data is found on the desktop, which is DEM tutor. This is the DEM data. So this one is the data that you have. I have. So depending on this DEM data, you can simply delete the watershed. First, we have to check whether this data is basically having its own coordinate system or not, or whether it's projected or not. So we have to project the data into geographic coordinate system or the other coordinate system. We may have the UTM coordinate system. So what I need is right click on the DEM, go to properties. Then in this layer properties, you may see different properties of the layer. In the general part, you may see the different descriptions and the likes. In the source, you will see different information of the data. One time we have the raster data, so the raster data information will be displayed. The metadata, the display, the symbology. In symbology, you can simply change from a single color or continuous color to the classified one, from the structured to the classified one, with the different values of ranges that you can simply give, or you can use the default ones. But for now, our intention is to see whether this data is projected or not. Go to source and spatial reference, the XY coordinate system, which is WGS984, the UTM zone 37 nodes. So it's already projected, so we don't need to project. If you don't have the projected data, you have to project your data into the projection that you need. In order to do that, you have to go to the ARC toolbox. In the ARC toolbox, you may go to spatial analysis tool. In the spatial analysis tool, you may get not spatial analysis tool, and data management tool. In data management tool, you may get projections and transformations. So if your data is a shapefile, you may define the projection here, or if your data is the raster data set, you have to click on it and you have to project the raster data. Since we have the projected data, we do not need to put the data into the coordinate systems. Therefore, now what we will do is go to the spatial analysis tool, hydrology, and fill. Input the raster data. We have to drag down the DEM data into the box. Output the surface raster will be saved onto the place where you need to save. For the time being, I want to save here with the name fill. Save it, say it OK. So you will fill the data by using the fill dataset. So now we have done the operation of fill. Then again go to flow direction. The input raster will be fill, and the output flow raster or flow direction raster will be saved under your file name DEM tutor with flow direction FDIR. You can give a name that you want. Now it is simply doing the flow direction processing on the DEM data displayed on the window. So it may take some time, so we have to wait until it finishes flow direction manipulation. So the flow direction is manipulated here with different categories of numbers that you can see here on the left side of the layer. So again, now we will do the flow accumulation. The input raster dataset will be the flow direction. So FDR is our data. The output accumulation will be saved under the same file with the name FAAC. Then leave the others default as it is. Say it OK. So it's automatically tried to manipulate the flow accumulation. So we will see how the flow is going within the watershed with the different river networks on the flow accumulation dataset of the raster file. Well, now the flow accumulation is done. If we use zoom out here with the white color, you can see the flow with its range. But in order to see a better river networks within the flow accumulation dataset, we have to make some distinction between the very small rivers and some rivers having a better visibility with their flow characteristics. So we have to go to Arc Toolbox, and again in the Arc Toolbox you may go to the spatial analysis tool. In the spatial analysis tool you have to go to map algebra. In the map algebra we'll get raster calculator. So our input data or layer, what we call variable, will be the flow accumulation greater than or equals to 500. So the flow accumulation greater than or equals to 500. I will give the name like this under the same file or directory. So let's say OK. Now it calculates the flow accumulation of having those greater than 500. So you can see the different characteristics of the flow are found. So it's better to visualize the river networks whenever we make it more clear. So now we have to delineate the watershed. In order to delineate the watershed, we need to know the outlet of the watershed. So if you have the outlet with the Excel file, you may simply add the Excel file in the shape data in order to delineate the watershed. If you don't, you have to manually add that data as a name per point. So in order to do that, let's create a new shape file within the ARC catalog. Click on ARC catalog, go to where the DEM data is found here. Right click on it, go to new, and let's say shape file. The shape file will be having the name per point. The feature type is point. If it is line, polyline. If it is polygon, you can say polygon, multi-point, the likes. But for the time being, it's point. So in the description part, you can see it says unknown coordinate system. So you have to project it with the coordinate system. This is projected coordinate system in the UTM zone, WGS 1984, in the northern hemisphere, where Ethiopia is found in 37° north. So I will select this one. You can select the coordinate system depending on the place or the country where you are belonging in. So if you need the watersheds having different UTM zone, you can use that UTM zone. For the time being, since I am here in Ethiopia, so I'm using the projected coordinate system with 37° north. That's the location. So let's say okay. So an empty shape file, not referenced shape file, is simply created here. So this data of the per point have to put on the place where we need to delineate the watershed. So you have to know where your watershed is found. So let me select some point around here, so let me say this is my watershed. So I will select this as an outlet. The outlet for the watershed will be here around. Let's say this is the outlet for the watershed. So let me select this one. Now let's select this one. You have to go to editor toolbar, or if it's not found, you have to do right click on it and go to the place where editor is found. So you have to check it. If it is not here, right click and check on the editor option. So in the editor option, start editing. What is edited? Per point. Okay, right? Then again on the editor toolbar, you will go to editing window. Now we will create a feature. The feature is point, so I will put a point on it. So now I have put the outlet point, so I'll say stop. Do you want to save your edits? Yes, I want to save it. So now I have the outlet which is put on the place. So now let's delineate the watershed. Go to Arc Toolbox, go to Spatial Analysis Tool. In Spatial Analysis Tool, let's go to Hydrology and Watershed. Input data will be the flow direction. The per point data will be entered to the outlet of the watershed, and let's say watershed. The raster data will be saved. So say it okay. Now the watershed will be delineated from the DEM. So So now we have the delineated watershed here. You have the watershed here as delineated. So let's extract. Let's extract the watershed from its the larger extent of DEM. So go to the arc toolbox, spatial analysis tool, and go to extraction. Extract by mask. The input raster will be, let me say, fly accumulation 500. The feature of the mask data will be the watershed. The place where you need to put the watershed will be flow accumulation. Flow accumulation, watershed. Let me say save it. Okay. Now it is extracted by mask. So you can see here we have the flow characteristics within the watershed, how the flow is going on. And again, extract by mask. The input raster will be the DEM data if you need the DEM data of the watershed, and watershed will be the mask for extraction. Let's say DEM watershed, DEM data of the watershed. Now the DEM data for the watershed is also extracted. This one is the DEM, as you can see. And again, let's go to arc toolbox and extract by mask. If you need to extract any data here, you can, but it's enough for extraction. Now, if you want to have the shape file for the DEM data or the watershed, so you can convert. In order to convert, go to arc toolbox in conversion tools. In conversion tools, from raster to polygon. The input raster will be the watershed. This one is an optional, so the output polygon will be the watershed. Watershed of feature class. Save. The name is existed. Now let me say watershed shape. Let me say shape. Okay. So the shape file for the watershed is created. Therefore, let's remove this one. Remove this one. Remove this one. Remove this one. It has to be removed. Field data will be removed. DEM data will be removed. Let me say go to the content, zoom to layer. Zoom to layer, yeah. So you can see if you uncheck this one, this is the DEM data for the watershed. You can change the color ramp like this. You will see this is the DEM data for the watershed. Or you can see this one is again the watershed with its flow characteristics of the river, how the river flows, where the outlet is found. Again, you can put it above to see which one is prior to you. So this is a way how you can delineate the watershed by using DEM data and also pull point on the outlet. Thank you for your listening and great attention. If you have any informations or ideas to consider here, you can ask anytime on the comment below. Thank you so much.